Okay, so we were just discussing the AP review schedule. First one, for anyone that's absent, is tomorrow, Thursday, 2 to 4. Okay. So tonight, your homework is going to be in the 2003, and I know a lot of you have started that. And there's no calculator, so please don't use a calculator when you're doing it. Do the best you can. Now, there's a video explanation of every single problem on this, on both my e-board and my YouTube channel. So if you get stuck, you can check. That's what you got to do. All right, so I thought that for a little warm-up today, I call these U-sub quickies. I don't think maybe that was a good name for it. Yeah. All right, well, here's the thing. You don't have to write it all out, U equals du. When all you're missing is a constant for du, like in this one, what constant are you missing? 5. So what are you going to have on the outside? 1/5. And then you can just write it out. You know that the antiderivative of e to the u, as long as you have du, is e to the u. So with all these, you're just missing a constant. You're probably going to have to write out this one with the little u sub. This one over here. But see how many you can do just by looking at them. Thinking about what do I need, so I'll have the reciprocal on the outside, and then I know my antiderivative. All right, I'll check the homework real quickly at tables, and then we'll go over a bunch of stuff. We got to get cracking here. Okay, guys, so for the first one, what would we get? We said we needed a 5, so we'd have a 5th on the outside. So what would the antiderivative be? E to the 5x plus c. Now, I didn't write it out. If you wrote it out, u equals 5x, du equals 5dx. You put in 5 to it. So I'm trying to do these where you don't have to get all fancy. How about the one underneath it? What are you missing? 7, right? So if you had to put a 7 in, what are you going to have on the outside? That's the important thing. 1/7. So it's like now you have 1/7 cosine u du. So we know this one. So what's the answer going to be? 1/7. What did you just say? You were the cantor. 1/7 sine of 7x plus c. All right? Yeah, and if you need me to, I'll go back and I'll show you with the with the formal u sub where you write out what u equals. But isn't it fun when you can just look at it? All right, so this next one, what would you need? Yeah, you need a 1/5 on the outside because you need a 5 in here. So now it's like 1/5 the integral of u to the 9th du. So if you were to integrate, let me leave that 1/5 here for a second. If you integrated u to the 9th du, 1/10 u to the 10th. So you'd have 1/10 of this to the 10th. 5x plus 7. So 1/50th you'd have out front. 5x plus 7 to the 10th plus 7. All right? See it or no? Ooh, there's one that in order to have du, if u was 3x, what would we need? We need a 1/3 on the outside because we need to put a 3 in here. So yeah, when you integrate secant u tan u, as long as you have du, it's just, say it again, Jillian? It'd be the secant of 3x plus c. You have to know that secant tan is the derivative of secant. So the antiderivative of secant u tan u is secant u. All right, the next one, we are missing a 4, so we have to have a 1/4 out here. Now it's a du over u. So when you integrate 1/4 the ln x minus 1 plus c. Yeah. Yes. I'm trying to think. We forget about it when we do the differential equation problems and we say, oh, it's because the quantity always makes what's inside positive, so we always don't worry about it. But those population problems, But if you want to be safe, you can just always put it and then just drop it when you exponentiate. Now, this one I think we'll do with the formal u sub because it might be a lot to juggle in the brain. Well, let's think about well, first of all, what would you make u? The 3x minus 1. So du, 3 dx. So we definitely need a 3, and then on the outside, 1/3. Now, let's actually rewrite this integral in terms of u and du. So we've got 1/3 the antiderivative of, in terms of u, what is it? Du over the square root of u. Right. So when you have du over the square root of u, it's not an ln, you bring that up, so you're integrating u to the negative 1/2 du. Now we can use the power rule. Loud. Okay. So yeah, the antiderivative of u to the negative 1/2 is 2u to the positive 1/2, or 2 rad u. That's fancy. So we could just write 2/3 rad u, just 3x minus 1. Yeah? Nice. Just going to keep practicing little by little, because usually on the AP exam, that's the type they like. Little u subs. See? That's good. Okay, so now we have free response questions from motion that I never got to, and table problems. And I want to go over whatever you guys want to go over. Now, I gave you the answers to the tables. Second motion we went through. Okay. Well, you tell me, give me a year and either motion or table. Oh, wait, the birthday girl's asking, sorry. Emily's birthday. Tables? Oh my gosh. 2014. So go through. We can go back and forth. So this is, 2000. Okay, now we're in 2014. What about parts before that? Want to go over any of the parts before that on 2014 while we're here? I don't mind going to different problems, but if we're in a problem, we can. B? Okay. So let's see, they gave us, do the data, because that's not funny, do the data in the table. Isn't that weird? As you always think does, but I don't know, maybe, is data the plural? It's both? Yeah, you might want to ask your English teacher about that. Do the data support the conclusion? I got definitely derailed here, but this little train here. Okay, that the train's velocity is negative 100 meters per minute at some time t, between 5 and 8. Okay, well, at time 5, its velocity, I'm just making sure I'm looking at the right one, is 40, and at time 8, it's negative 120. In order for it to have to go through negative 100, so think about it, it's going from, at time 5, the velocity, let's say this is the velocity today, is 40. And then at time 8, it's negative 120. It would have to be, as long as this is what kind of a function, continuous. It doesn't matter if it's all jaggedy and has corners. We don't care about that. But as long as it's continuous, it would have to. And you have to just remember, we only have a couple of theorems that we have to know, and I will spend a little. And this is, when you say that a graph has to go through all the y coordinates, if it's continuous, that's the intermediate value theorem. Yeah. Yeah, you just say by the IVT, there must be a value between 5 and 8. Yeah. But yeah, I would say it's continuous. What did they write on the answer key for that one? They would probably accept it. It's so good when you just say the IVT for saying it has to go through all the Y's. Yeah, because it's continuous, there has to be a value. Yeah, I think they would accept that. Um, yeah. Okay, so that was B. So part A was okay. Okay. Um, was C okay? Oh, I think people asked me about C. C. Not as bad. Let's see. At time two, trainee's position is 300. Blah, 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 blah. Write an expression. Oh, I love these. That means no work. Write an expression involving an integral that gives the position of A at time 12. For position, are we using X or S? Does it matter? I guess not. What do you guys want to use? S? So we want to come up with some expression for the position at time 12. Um, and we want to use a trapezoidal sum, blah, blah. Okay. Well, the first thing that they gave us, they told us at time 2, its position is 300. So that's your starting point. So we're going to use, so the position at time 12 equals the position at time 2 plus, how are you going to get the change in position? You guys are good. The integral of what? From 2 to 12 of the little velocity there. I guess you call it that. Okay. Now, the part that we're going to approximate is the definite integral part. Okay, the 300 just is 300. So I got to go and I got to approximate that. Now, it's only from 2 to 12. So they might have thrown you off. They might have said, oh, there are too many points for just 3 trapezoids. There were 5 points. But if you just go from 2 to 12, that's perfect. You see that? We have 4 points there, so we can have 3 trapezoids. Now, oh, I don't want to do that. Is the height of each trapezoid going to be the same or different? Different. So the only thing we can pull out is the half. I'm going to do this part up here, and then I'll drag it down, because I have that kind of power. So it's to have the half. Now for each trapezoid, we have to do the height times the sum of the bases. So for the first trapezoid, what's the height? 3. And then sum of the bases, 100 plus 40. So 3 times 100 plus 40. Please don't forget the half when you're doing the trapezoid. Okay, for the next trapezoid, I can't reach, what's the height? 3. And what do I write down for the sum of the bases? Yeah, so plus negative 120 minus. Okay, and then the last one, plus 4. You know what? Let's just add them together. What do we get if we add those? Negative 270. All right. And then I close that. Oops. All right, so that's what's going to go over here. Now, was this the one we were allowed to use a calculator with? No calculator. Well, but you could leave it like that. It's just multiplication addition. If it's just arithmetic, technically they got to accept it if you leave it, that whole junk, you bring it down here. Yeah, you could. Yeah. Yeah, you don't have to do arithmetic. Yeah, and I'm going to ask her again. In fact, it bothers me. No arithmetic simplification has to be done. And yet, if you do it, you lose points. Because I asked this person who was there grading last year, and I said, really? So if a kid doesn't get it wrong, they lose a point? A kid who doesn't do it, safer to leave it. No one's going to think bad of you or your family if you don't. So I know that you probably are worried, like, I will bring shame upon my family if I don't simplify it. But, yeah, if you don't have a calculator, so, okay, so we're going to leave it today. But don't forget it's 300 plus that. Okay. All right, now we'll do the D. That was the part that, oh, yeah, you know what I did? I made a mistake, though. This is what it actually equals, but then I should have said S of 12 approximately equals, and then put that whole thing in here. Right? Because that would be the real value, and this is just an approximation, because I'm not getting this definite integral. I'm approximating it. Yeah, okay. Let's see. D. Is this D? Okay, a second train, B, travels north. I haven't even been reading this problem, but all right, they give nice equation for V's velocity. Time 2, Find the rate in meters per minute at which the distance between train A and B is changing. This is the related rates they threw in here. Just remind me. So in this problem, you've got train A. He's going east. Okay. So let me just do this. So I'm just. Oh, you know what? I don't want to have that whole axis here. That would be bad. So train A is going east, and then train north. Okay. I'm just going to call this whole distance here B, between here and wherever. Was this a place like? Oh well, it's a train station. Okay, and that'll be. This will be distance A. Okay, and they're asking you, and they already gave us. Let's see. Well, let's see what they're asking for. They gave us the rate at which B is changing, right? And they want to know the rate at which the distance between them is changing. So we're going to label that C, unless you're a crazy person, you label it something else. Yeah. And they want to know the rate at which the distance between them is changing. So what are they looking for? CDJ. At the time t equals 2. Now, whenever you have, like, you're given, we do know how these quantities are related. I'll do this part first. So what's the equation that relates A, B, and C? A squared plus B squared plus C squared. Yep. Once you write an equation that relates to the quantities, then you take the derivative of both sides with respect to t. So if it's not a t, you got to remember you need to d that dt. So what's the derivative of this side going to be? 2a dA dt. Okay, now we're looking for dc dt at the moment when t is 2. So we got to fill in everything else. So do we know what A is at time 2? Do we know it's... Now, was that given to us? Okay. So when t equals 2, because this is the plug and chug time, A equals 300. At t equals 2, what's the velocity of train A? Was that given in the chart? 100. 300, yeah, kids, where'd you get that from? At t equals 2, oh, they told us its position is 300. Okay, got that. All right, where are we up to? Let's see. Okay, so from the chart, we know that A's velocity, dA dt, is 100. What about B, the distance from the train? The, oh, wait, this is all at time 2. Oh, no, they told you it's 400. Okay, I got that. Oh, you're saying the other thing. I don't know, I didn't knock off all the 2's. Oh, well. They gave us that. dB dt is going to be the velocity of train B at time 2. All right, let's plug 2 into that, to this. So V, so 2 squared would be 4 times negative 5. That's negative 100 plus 120 plus 25. 45? Negative 5 times 2 squared? Oh, yeah, what was that? I think yeah, I don't know what I was doing. Thank you. So it's negative 20. Now I got to erase. 125? Okay. Yeah, no, that was my fault. So 125. And the only thing we have to fill in now is the C, and then we can figure the rest out. Now, we said at this moment in our little right triangle, A was 300. Oh, I love these numbers. B was 400. So at that moment, C is 500. Now, I would definitely get rid of all the 2's, just divide both sides by 2. So we have, if I knock these off, so we have 30,000, 4 times 125. That would be 500. Wait a minute. Let's see if that, is that right? I got the right number of zeros here? Wait, yeah, I think I need one more zero. Yep, I do. Okay. Equals 500 CDT. So 80,000 over 500. Ooh, that's pretty fast. Yeah, you can. Yep. 16. Is that the right answer? Whew, that seems fast, doesn't it? I don't know what the units were in this one. Is this 160? Oh yeah, 800 over 5. Wait a minute. Yeah, that is 160. What were the units though in this? Was it meters? Meters per minute. Okay. Now we have to write that. Yeah. I mean, you got to get DC. You have to get it by itself. You know, you can't just leave like this line. Nice. Okay, what do we want to go over next? Oh man, time is always so short in these periods. It's the best. Pick either a motion or a table problem. 2013. What was I just? Okay, that was 2014. Okay, I love this, and this was a no calculator. Okay, so now all of a sudden they introduce an equation. The amount of coffee in the cup in ounces is modeled by this equation, B of T. Using this model, find the rate at which the amount of coffee in the cup is changing. When you see that, the rate at which something's changing, what do you think of? The rate at which anything changes is its derivative. So they're saying, find the rate at which the amount's changing. So find the derivative of this function when t is 5. So I've got to get the derivative of this function without a calculator and plug in 5. Well, it's not so bad. So we want to get b prime. You always have to get the derivative first before you try to plug a number in. Okay, well, I'll do the derivative of 16. Got it? Okay. Now, you could have called it, all right, honestly. So, well, what's the derivative? Now, right now we have to take the derivative of negative 16 times something. So what do we do with that negative 16? Well, it's just, we don't have to use product rule if it's just a number. What do you do with the constant multiplier when you're taking derivative? Leave it. Oh, we have to copy it down. Okay, so far, not so hard. Now, if it was like 4 times cosine, you leave the 4. The derivative of the 16 that's by itself, that's 0. Oh yeah, this is not, you're thinking like with the power rule, when you bring it down, that's when the power is a constant and the base is the variable in it. So now we just use the e to the u rule to take the derivative of e to the u. It's e to the u times u prime. So we just copy the e to the negative, bless you, e to the negative 0.4t, and then we have to multiply by u prime with negative 0.4. Now we just have to plug in 5, and we've got it. So it's negative 16 times e to the negative 0.4 times 5, and then times negative 0.4. You know that 4 times 16 is, you know what 4 times 16 is? 64. So let's just move positive 6.4 e to the, okay, so negative 2, right? You know 4 times 5 is 20, but since it's 0.4, you move the decimal back one, so it's just 2, and it's negative. Oh, you can still fit another one in. What else we got? If you left it like this is the question. I think so. I'm going to call this person and make sure, like I'll have specific questions. Yeah, I have a person who went there last year, and it's just so hard for me to stomach it because I never told the kids don't simplify arithmetic. Even though it said it, I never made a point of making it an issue because I thought it. Yeah. Well, like when you're doing all the practices, keep trying to do it so you can check if your answer is right when I give you these keys. But yeah, I don't think I think this would have been fine. I just wonder all the points that my kids have lost in the past because I just felt too uncomfortable telling them don't simplify. Yeah, the math teacher, like I feel like you're doing something wrong. It's rude. I don't know. Was there another one you want to try to get in here? Can you start liking tables a little bit? You never just. Which one? From this one? B. Is there a time? Yeah, I'm so glad you said that. Is there a time where the derivative has to equal 2? Between 2 and 4. So what you do is you find the slope, the average rate of change between 2 and 4. Okay? So if you find delta C over delta T, it's 12.8 minus 8.8 over 4 minus 2. And if you do this, it's 4 over 2, which is 2. Now, you just found out between those 2 points, the average slope, the slope of the secant, equals 2. If this is what kind of a function does it have to have a point in there where the tangent has a slope of 2? This is one of the theorems that says as long as it's continuous and differentiable, this is mean value theorem. Somewhere the slope of the tangent would have to equal the slope of the secant, the average rate of change. Yes. And the reason I would know to do this, you're probably like, how would you even know to do that? Because they're talking about, they gave me the interval. And they're talking about the derivative. And with a table to get the derivative, to approximate it, you use the slope formula. And yeah, as long as they tell you that it's differentiable, there you go. You just say by the MVT, there has to be a value between 2 and 4 such that the derivative is 2. 15 minutes each. When you've practiced enough, usually time is not an issue. You know, when you've seen enough of these. There are going to be parts of questions that are going to come out of nowhere. But you just got to keep up with it. You guys are doing well. Work hard on these multiple choice tonight. Do what you can. And remember, you can look at videos. Yes. And it's me this time.